If there were a contest for the most spectacular auroras in the universe, Jupiter would win by a landslide. Its auroras are bigger, brighter, and more numerous than any other planets in our solar system, and they even emit X-rays. So how does Jupiter make such bright auroras, and why do they break physics? If you've ever seen an aurora on Earth, then you know they can be pretty amazing. These beautiful displays of light happen when charged particles from the Sun interact with atoms in our upper atmosphere. When the particles collide with the atoms, they cause them to glow. The color of the glow depends on what atom is being hit. For example, oxygen tends to emit green or red light, while nitrogen makes blue or purple auroras. Now, it turns out that auroras aren't unique to Earth. Any planet with an atmosphere and a magnetic field can get them. But for some planets, their auroras might be more impressive than others, like Mars. In 2020, NASA's Mars Global Surveyor spacecraft photographed the red planet's first ever aurora. It was spotted near the Martian South Pole and glowed a mysterious blue color. Scientists think the blue Martian aurora might have been caused by an unusual type of particle, perhaps ionized hydrogen. Auroras like this could help scientists understand whether or not there is any sort of magnetic field at Mars' core. If there is, it may help explain why Mars still has an atmosphere today. But Mars's auroras are nothing compared to Jupiter's. First, let's talk about why Jupiter has auroras in the first place. You see, the Sun constantly emits a stream of charged particles called the solar wind. When these particles reach a planet with a magnetic field, they get funneled towards its poles. There, they slam into the planet's atmosphere and produce auroras. But Jupiter's auroras don't just get powered by the Sun. They're also stoked by volcanic activity on Jupiter's moon Io. About the size of Earth's moon, Io is covered with volcanoes that spew out lava and sulfur. In fact, it's the most volcanically active body in the solar system. What happens is that the volcanic activity on Io creates a sort of magnetic field. It's very weak compared to Jupiter's own magnetic field, but it's enough to send charged particles raining down on Jupiter's surface. These particles come from Io's volcanic plumes, which are full of sulfur and oxygen ions. Some of those particles reach Jupiter's upper atmosphere and produce auroras. And because the volcanic activity on Io is constant, Jupiter's auroras never go away. They're always there, glowing above Jupiter's north and south poles. The first person to observe them up close was Galileo Galilei, back in 1610. He saw them during one of his observations of Jupiter with his telescope and described them as a beautiful shining, a kind of starry light. Now we know they're not stars, they're auroras, but Galileo didn't know that yet. In fact, he was actually convinced that Jupiter was emitting light from its surface. So when he saw the auroras, he thought they were part of the planet itself. He even tried to measure the brightness of the light coming from Jupiter's auroras to see if it changed over time. Unfortunately, Galileo's equipment wasn't sensitive enough to detect any change in brightness. But modern instruments have had much better luck, and what they've seen is totally shocking. It turns out that Jupiter's auroras vary dramatically over time, and they're brighter than anything else we've seen in the solar system. Take, for instance, the Hubble Space Telescope. Back in 1992, the telescope was pointed at Jupiter, and it picked up auroras at both of the planet's poles. They appeared to be oval-shaped, and they were way brighter than anything Earth has ever produced. Then in 1994, the Galileo spacecraft arrived at Jupiter and started making observations of its own. One of the things it did was drop a probe called Galileo probe near GPN into Jupiter's atmosphere. This little probe was designed to make a parachute descent through the planet's upper atmosphere. But it had a bit of a problem. It was supposed to deploy a parachute at 150 kilometers above Jupiter's surface, but it failed to do so. As a result, GPN fell all the way to the ground before it finally broke apart, and during its fall, it measured things like temperature, atmospheric pressure, and yes, auroral brightness. At its brightest, the auroras were around 10 times brighter than they are here on Earth. But that's not even the entire story, because auroral brightness is actually measured in a unit called the KP index. The higher the KP index, the brighter the auroras. And the strongest auroras ever recorded on Jupiter have an index of around 21. Here on Earth, the strongest auroras usually max out around a Kp index of 9, so that's great. We've established that Jupiter's auroras are bigger than ours. But that still leaves the question of why they're able to break physics. You see, when the particles from the solar wind and Io slam into Jupiter's atmosphere, they transfer energy to the gas molecules below. Most of the energy goes into kinetic energy, which is the energy of motion. The molecules start moving faster and the air gets hotter. But some of the energy can also be converted into light, which is electromagnetic radiation. Visible light is just one type of electromagnetic radiation. There's also X-rays and gamma rays. And believe it or not, Jupiter's auroras emit both of these forms of radiation. In fact, they emit so many X-rays that they were discovered more than 30 years before we ever saw the auroras themselves. Back in 1972, NASA launched a pair of satellites called the Explorer 47 and 48. Their mission was to study the X-ray emissions from the planets in our solar system. When they reached Jupiter, the satellites detected a huge amount of X-rays coming from its poles. Scientists were shocked. They knew Jupiter had strong magnetic fields, but they had no idea it was emitting so much radiation. To this day, we're still trying to figure out exactly where the X-rays are coming from. There are several competing hypotheses. Some scientists think the X-rays are produced when charged particles from Io hit Jupiter's atmosphere. Others think they're created by the intense electric fields near Jupiter's magnetic poles. But it's possible that both of these processes contribute to the X-ray emissions. What we do know is that these emissions are extremely bright. The X-rays produced by Jupiter's auroras are the brightest we've ever detected from a planet. The only thing that comes close is Saturn, and that's probably not a coincidence. Like Jupiter, Saturn has a moon that's volcanically active. It's called Enceladus, and it produces a lot of the same kinds of charged particles that Io does. As a result, both of Saturn's poles also emit bright auroras, and yes, they also emit X-rays. So what does this all mean? Why should we care about auroras on faraway planets anyway? Well, auroras are more than just beautiful displays of light. They tell us a lot about the inner workings of planets and their atmospheres. The colors tell us what elements are present, and the brightness tells us how fast the particles are moving. By studying auroras, we can learn more about how atmospheres interact with magnetic fields, and by doing that, we can better understand our own planet. Here on Earth, auroras are a reminder of the power of our sun. They show us the dynamic range of our solar system, and they break physics by producing emissions that we can't recreate here at home. But maybe one day we'll be able to harness their power and put it to good use. Who knows? Maybe we'll build cities on Jupiter's moons or terraform Mars so that we can have red auroras on demand. We don't know what the future holds, but one thing's for sure, it'll be wild. Thanks for watching this episode of Show Space. If you want to help keep our content free for everyone forever, you can join our community on a crowdfunding platform. This platform is a great way for us to connect with you and get your input on what we make. Plus, there are some exclusive perks like blooper reels, a digital studio tour, and even live streams. So visit our page to learn more and join today.